Dear friends, in last video we have seen different formulas to calculate t value in different situation. In this video we will see how t-test is used to check the significance of difference between two uncorrelated means when sample is large. Your example is given, two samples, boys and girls are given. Number of boys is 21, that is N1. Number of girls is 18, that is N2. X bar 1 is the mean of the scores of boys, that is calculated by using normal formula of mean. X bar 2 means mean 2, means the mean of the scores of girls is 31.6. It is also calculated by using normal formula of mean. Then uncorrelated means are given and large sample is there. Then we have to find SD1 also to find to calculate t value. So here SD1, standard deviation of the scores of boys, is calculated by using normal formula of SD, and that is 5.51. SD2 means standard deviation of the scores of girls. It is also calculated by using normal formula of standard deviation, that is 4.23 here. SD1 square is equal to 5.51 whole square equals to 30.3, and SD2 square equals to 4.23 square equals to 17.9. These are basic calculation which are to be used to find t value and standard error of difference between means. And formula, as we have seen in last video, for large sample and uncorrelated means are given, then to find standard error of difference between means, this formula is used. We have found all the values, we put all the values. SED equals to under root SD1 square upon N1 plus SD2 square upon N2, where SD1 square is 30.3 as we have calculated, and N1 is 21, SD2 square is 17.9, and N2 is 18. By solving this, we will get under root 2.43, and by taking the root of 2.43, we will have 1.56, that is standard error of difference between mean. So, dear friends, after doing primary calculations required for the t value, now we'll put all the values in the formula of CR, critical ratio, or t value. Primary calculations are given here, and the formula of critical ratio or t value is given here, that is CR equals to in modulus x bar 1 minus x bar 2 upon ACD. In previous video we have discussed that sometimes in some cases t value is called critical ratio, and in some cases it is called t value. Now we'll put all the required values in this formula. X bar 1 is 35.6 and x bar 2 is 31.6. Both are put in modulus with minus sign in between, and upon 1.56, that is ACD, as we have calculated earlier. By solving this, we will get CR equals to 2.56. That is also called T calculated, because we have calculated this value. T cal means calculated. Now friends, after finding t value, we have to find df. Df is degree of freedom. When uncorrelated means are given and sample is larger than, to find df, this formula is used. Df equals to n1 plus n2 minus 2 N1 is 21, N2 is 18 minus 2. So df equals to 37. After getting these two values, df and t calculated, we have to refer the t table. This is t table that is divided into two parts as shown on the screen. Generally it is found in all the statistics books. In this table 5 columns are given, more than 5 columns may be there, but generally in psychology, education and social sciences, significance of the difference between means is checked at 0.05 level and 0.01 level. How to check it? For that we have to remember our df, that is 37, and our t calculated, that is 2.56. We have to compare that value with this table value. For that, under the column of df, we have to see 37 because our df is 37. In first part of the table, the last value under the column of df is 30 and our is 37. So in second part of the table we have to see, and in second part of the table under the column of df 35 is given, then 40 is given, 37 is not given. In such cases we have to see the nearest value of our df. So our df is 37 and here df 35 and 40 are given. So out of these two, the nearest value is 35, so we have to see 35. Now we have decided our df, that is 35. Now we have to see in that row under the column of 0.05 level, we have to see that value 2.03, and under the column of 0.01, that is 2.72. 2.03 is required table value for significance of difference between means at 0.05 level, and 2.72 is required table value for significance of difference between means at 0.01 level. We have to remember these two values, and we have to compare our t calculated with these two values. So t table value required at 0.05 level and 0.01 level are 2.03 and 2.72 respectively. We have to compare our t calculated 2.56 with these two values, and by comparing it, it is found that our t calculated is greater than t table value at 0.05 level, because required t value at 0.05 level according to t table is 2.03 and our t calculated is 2.56. In such case, if our t calculated is greater than required table value, then the hypothesis is rejected. So in this case, the hypothesis is rejected at 0.05 level, not at 0.01 level, because the required t value at 0.01 level for significance of difference according to the t table is 2.72 and ours is 2.56, means our t calculated is 2.56, that is smaller than 2.72, that is required t table value at 0.01 level for significance of difference between means. But here our t calculated is greater than t table value required at 0.05 level for significance of difference between means. So the null hypothesis will be rejected and it is concluded that there is significant difference between the means of boys and girls. In this way, in this video we have seen how to use t-test when uncorrelated means are given and sample is large. In next video we will see uncorrelated means and small sample. If these two are given, then how t-test is used. Till then, goodbye.